Welcome back to it. It's Maths Masterclass with Leo. Today we are doing one of the nicest topics, which is a differentiation of a quotient. Right? In the previous videos, we did introduction to differentiation. We also showed you how to differentiate a product. So today we're differentiating a quotient. Say a given y is equals to u over v. Right? They want you to differentiate this where both u and v are functions. Right? So you need to differentiate this where both u and v are functions. So this is a function divided by a function. So when you're differentiating a function divided by a function, you will start by differentiate this with respect to x. It will give you dy over dx. This is equals to, now you differentiate your numerator while keeping your denominator constant. It will give you v multiplied by du over dx minus, now you're differentiating your denominator while keeping your numerator constant. It will give you u multiply dv over dx, all divided by v squared. So the order is very much important. The first thing, you need to differentiate your numerator and keep your denominator constant always. So the order is very much important in this case. Differentiate your numerator, keep your denominator constant, and then differentiate your denominator, keep your numerator constant. Don't swap around this order. If you swap the order, your answer is going to be wrong. Let's say they gave you in terms of f of x is equals to h of x divided by g of x. Right? So they want you to do what? They want you to differentiate this. Still, we're going to do the same thing, apply the same thing. Differentiate this, it will give me f prime of x, which is equals to differentiate my numerator while keeping my denominator constant. It means I'll have g of x multiply h prime of x minus, now I'm going to differentiate my denominator while keeping my numerator constant. This will give me h of x multiply g prime of x, all divided by g of x squared. Right? That is how I'm going to differentiate a function divided by a function. Now let's get problems. Let's get to do problems. Say a given y is equals to 4 sine of 5x divided by 5x squared. So you can see that you have a trigonometric function divided by a parabola or a quadratic function, right? So in this case, we have trigonometric function and a quadratic function. So we need to differentiate this. When differentiating this, I'm going to get differentiate y with respect to x. It will give me dy over dx. This is equals to, now differentiate my numerator while keeping my denominator constant. I'm going to get 5x squared as it is into my numerator. It will give me 4 multiplied by 5 cos of 5x, right, minus, now I'm going to differentiate my denominator while keeping my numerator constant. I'm still going to have 4 sine of 5x into, this will be 4 times 2x 2 minus 1, right? And then from there, divide this by 5x squared in bracket squared. From there, I can further simplify. So 4 multiplied by 5 is going to be 20. 20 times 5 is going to be 100. 100 x squared cos of 5x, right? And then minus, here I have 5 multiplied by 2, which is 10x. 10 multiplied by 4, it's 40x sine of 5x. Divide this by, it's going to be 5 squared is 25. X squared to the power squared is x to the power 4. And then from there, this, I can take out a common factor of 20. 20x into 20 if I take out 20x, I'm going to be left with 5x cos of 5x minus 40x divided by 20x. This will give me 2 sine of 5x. Divide this by 25 x to the power 4. Then 5 goes into 20 and 5 goes into 25. Also x goes into x goes into x to the power 4. This will give me 4 over 5 x to the power 3 into 5x cos of 5x minus 2 sine of 5x. That is my solution for this question. Hope it makes sense. Let's get another one. Let's get another question. Say now you are given y is equals to tan of ax. Most of you know that the differential of tan ax is equals to a sec squared ax, but you don't know how we got to that point. Let me show you. Here, I know that tan of ax is an identity, and that identity is equals to sine ax over cos ax. Right? Now, when I differentiate this, I'm going to differentiate my numerator while keeping my denominator constant. This will give me dy over dx is equals to, differentiating my numerator, I'm going to have, okay, keep this constant, I'm going to have cos of ax in bracket. When I differentiate my numerator, I'm going to have a cos of ax minus, now I'm keeping my numerator constant, which is sine of ax. Then differentiating my denominator, I'm going to have negative a cos, negative a sine of ax, because I'm differentiating my denominator, which is a cos. Differentiating cos, I'm going to get negative sine. Divide by cos ax all bracket squared. This is equals to, now this will give me a cos squared of ax minus into negative a sine squared of ax. Divide this by cos squared ax. This is equals to, now from here I'll have a cos squared ax plus a sine squared ax. Divide this by cos squared ax. Then take out a common factor of a into cos squared ax plus sine squared ax. Divide by cos squared ax. And from there, a multiply 1 over cos squared ax. Why do I say 1? Cos squared ax plus sine squared ax is an identity, and that identity is equals to 1. So now, 1 over cos squared ax is sec. This is dy over dx is equals to a sec squared ax. That is our solution for this question. Let's get another one. See, now you are given, let's see this one, you are given y is equals to t e to the power 2t. Divide this by 2 cos of t, right? So they say differentiate this. You can see that the top part, it has two functions already. So it's a function multiplied by a function divided by a function. So in this case, we don't forget that this part represents a product, right? So we need to use the product rule here, as well as using a quotient rule. So let's start. So this will give me dy over dt is equals to, now I'm going to keep my denominator constant, which is 2 cos of t into, now when I differentiate this, I'm going to start by differentiating t. When I differentiate t, I'm going to get 1 multiply by this is my constant, e to the power 2t plus, now I'm going to differentiate e to the power 2t. while keeping t constant. I'm going to have t multiply 2e to the power 2t, right? Minus, now I'm going to differentiate my denominator, which will be t multiplied by e to the power 2t, in bracket, into negative 2 sine of t, all divided by cos squared, or let me just say 2 cos t squared. Then from there, this will multiply everything inside the bracket. So here I'm going to have 2e to the power 2t cos of t plus 2 multiplied by 2 is going to be 4. Means this is 4t e to the power 2t. And then cos of t minus, in bracket, this will be 2 minus 2t e to the power 2t sine of t. Divide this by 4 cos squared of t. Then this is I'm gonna take out a common factor here, or before I take out a common factor, let me try to simplify it. This will be 2e to the power 2t cos of t plus 4t e to the power 2t cos of t plus 2t e to the power 2t sine of t, all divided by, divide this by 4 cos squared of t. Then from there, I'm going to say, take a common factor of 2 e to the power t. So I'll have 2 e to the power 2t into, I'll be left with cos of t, then plus, this will be 2t cos of t plus, this will be t sine of t. Divide this by 4 cos squared of t. Further simplification, 4 into this. So I'm going to be left with e to the power 2t into, or e to the power 2t over 2 cos squared of t into cos of t plus 2t cos of t plus t sine of t. That is my solution for this question. Let's try to get another one. Okay, then now say a given y is equals to 5x over 2x squared plus 4. So you can see this is a linear function, this is a parabolic or a quadratic function. So when I differentiate this, I'm going to have dy over dx. This is equals to 2x squared plus 4. Write it as it is, then differentiate this. I'm going to have 5 minus, now 5x. Differentiate this, I'm going to get 2 multiplied 2x to the power 2 minus 1. Then plus 0, I'm not going to write it. Divide this by 2x squared plus 4 squared. And then I'm going to have 5 multiplied by 2x squared, it's going to be 10x squared. 5 multiplied by 4, it's plus 20. Then minus, this is 5 in bracket. Then this is going to be 4x over 2x squared plus 4 squared. Then this gives me, see, it's going to be 10x squared plus 20 minus 20x squared over 2x squared plus 4 squared. Then this is negative 10x squared plus 20 over 2x squared plus 4 squared. Let me write this 20 clear. right? That is how you'll differentiate this type of equation. That is how you'll differentiate it. You can further simplify it if you want to, which will mean you need to simplify the bottom part or expand it. So this will give you negative 10 x squared plus 20 over 2x squared plus 4, 2x squared plus 4. Let's see. From there, negative 10x squared, is it plus 20? Let me see. Yes, plus 20 plus 20. Let me rewrite it. Divide by 2x squared plus 4, 2x squared plus 4. Okay, from there, I can say negative 10x squared plus 20 over this multiplied by that is going to be 4x to the power 4, and then plus 8x squared plus 8x squared plus 16, then negative 10x squared plus 20 over 4x squared plus 16x squared plus 16. Then take out common factor of 2. So on top I'm going to have 2 into, or negative 2 into 5x squared minus 4. This divided by 2 into x squared into 2x squared plus 8x squared plus 8. So this is going to be 2x to the power 4 plus 8x squared plus 8. Then 2 and 2 will cancel. I have my final solution as negative into 5x squared minus 4. Divide this by 2x to the power 4 plus 8x squared plus 4 plus 8. Right, that is my solution for this question. Let's see if I can get another one, which is the last one for the day. Y is equals to square root of x divide cos of x. Right, so in this case, the first thing is to change that. Y is equals to into x to the power half divide by cos of x. Then differentiating, I'm going to write dy over dx is equals to cos of x into 1 over 2 x to the power negative 1 over 2 minus x to the power half negative sine of, okay, we need some space. Okay, so still I'm going to have my dy over dx. This will give me cos of x into half x to the power half, which is negative half, then minus into, rewrite my numerator x to the power half, into negative sine of x. Divide this by cos x bracket squared, then this gives me 1 over 2 x to the power negative 1 over 2 cos of x minus, okay, minus going to be plus x to the power half sine of x. Divide this by cos square of x. See, I can't further simplify that, therefore I can rewrite it as 1 over 2 square root x cos of x plus square root x sine of x divide cos squared x. That is my solution. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Danko means thank you. Danko.